Hello, I am Varun from Kumar Girls Engineering College, Assistant Professor in Computer Science and Engineering. So today topic is mathematical induction. We are going to study mathematical induction. There is principle of mathematical induction that let Pn be a predicate defined for the integer n. Suppose the following statements are true. First step is the basic step, second step is the induction step, and last one is the inductive hypothesis. In first step, we study that the given function is true for some initial value, that is a, which belongs to the integer set z, and inductive step says that for all integer which is k greater than equal to a, if pk is true, then we have to show that pk plus 1 is also true. For inductive hypothesis, we use that if our predicate is true for 1, then it means it is also true for pk plus 1. It means it is also true for p2. And if our predicate is true for p2, then it is also true for p3, and so on up to infinite. So we can say that for all value of n, this particular function or predicate which is defined in the question is always true. Like this, if we take base case is p1, then if pk was true, then pk is true. It means pk implication with pk plus 1, we know it is true that p comma 1. It is the base condition or initial step, because pk is true and pk plus 1 is true. If p1 is true, then p2 is also true, and so on. So we can say that is true for all possible value of n. So take an example that sum of first n integer is always n plus 1 divided by 2. This is the formula which we have studied already in 11th or 12th class. Then how we prove that this particular predicate function is true for all value of n? So take a first step, that is the basic step. We take first term from both sides, we put n is equal to 1. So from left hand side, we take only one term, that is 1, and in right hand side we put n is equal to 1. It means 1 into 1 plus 1, that become 2, divided by 2, it is also 1. 1 is equal to 1, it means it is true for basic step. Okay, now inductive step. We assume that our predicate function is true for the k greater than equal to 1. So we have to show that it is also true for pk plus 1. So let's prove continue. The statement, if statement is true for k, it means 1 plus 2 plus k up to k, that equal to k into k plus 1 divided by 2. So we need to show it is also true for k plus 1. It means 1 plus 2 up to k plus 1, that equal to k plus 1 and k plus 2. We place k plus 1 in place of k. So our function and predicate function is like this. Like this. Then we expand our series like this, 1 plus 2 up to k and k plus 1. We assume that this particular statement is true for k. So we put value of 1 plus 2 plus up to k is k and k plus 1 divided by 2. So we write over here that k plus 1 by 2 plus k plus 1. We solve this equation, and what we will get? We get then k into k plus 1, that is k square plus k plus 2 multiplied by this to k plus 2 divided by 2, and we did the factor of this, that becomes k plus 1 and k plus 2, which is given as a pk plus 1. It means we proved the basic of inductive step. So we conclude that the given statement is true true for all value of integer n which is greater than equal to 1. So take one more example, that is 1 square plus 2 square plus up to n square is equal to n plus 1 and 2n plus 1 divided by 6. So very first step is the basic step. We substitute n is equal to 1. So we calculate the p of 1. We calculate p of 1. From left hand side it comes 1 square and from right hand side it is 1 dot 1 plus 1 and 2 dot 1 plus 1, which is becomes to this, that 1 dot 2 dot 3 dot divided by 6 become 1. Left hand side is equal to right hand side. It means our basic predicate function is true for value p is equal to 1. So inductive step, we assume that our statement is true for k greater than equal to 1. Then inductive hypothesis, we have to show that it is true for k plus 1. So according to our statement that pk is true, it means 1 square plus 2 square up to k square that equal to k plus 1 and 2k plus 1 divided by 6. And we need to show that it is also true for k plus 1. We place k plus 1 in place of k. So our equation is 1 square plus 2 square up to k plus 1 ka whole square, that is equal to k plus 1, k plus 2 and 2k plus 3 divided by 6. So we again expand our left hand side series, that is 1 square plus 2 square in such a way, this is that 1 square plus 2 square up to k square and plus k plus 1 square. For first part we have assumed that this value is true, so we substitute in place of this. Okay, then we place then k plus 1, 2k plus 1 divided by 6 plus k plus 1 ka whole square. What is the common in between this? That is k plus 1. That is k plus 1 and divide by 6. We take common, it means we take common what is the value of remaining value, that is 2k square plus k plus 6k plus 6, which is factorization and given the result k plus 1, k plus 2 and 2k plus 3 divided by 6, which is equivalent to the p k plus 1. So we proved the basic and inductive step. So we conclude that the given statement is true. If P1 is true, then P2 is true. If P2 is true, then P3 is true. If P3 is true, then P4 is true, and so on for n greater than equal to 1. For these values, our given predicate function is always true. So take one more example, that is 1 is ki power 3 plus 2 ki power 3 up to n ki power 3 that equal to n square into n plus 1 ka whole square divided by 4. So first basic step, that is n is equal to 1, that it means P1. The first term is 1 ki power 3 here, and from right hand side that is 1 ka square, that is 1 ka square dot 1 plus 1 ka whole square that divided by 4. That divided by 4. It means 1 plus 1 become 2, 2 ka square that is 4, 4 say 4 cancel, that it means 1 dot 4 divided by 4 that equal to 1. It means LHS is equal to RHS. Okay, for inductive step we assume that for some value of k greater than equal to 1, our function is correct, and we show that it is also true for k plus 1. So we assume that 1 ki power 3 plus 2 ki power 3, that particular function is true, that is k square and k plus 1 ka whole square divided by 4. And we need to show it for k plus 1, it particular function is also true. It means 1 ki power 3 plus 2 ki power 3 up to k plus 1 ka whole power 3 that equal to k plus 1 ka whole square dot k plus 2 ka whole square divided by 4. So we expand our series like this, 1 to k की power 3 and k plus 1 का whole cube, and we substitute this particular function in place of this particular series, because in step number 1 we assume that this particular function is true. So we substitute this and we take common factors, that is k plus 1 का whole square divided by 4, and remaining part is k square plus 4k plus 4 again, which is whole square of k plus 2. So it will become k plus 1 का whole square, k plus 2 का whole square divided by 4. It means that it is also true for all value of n greater than equal to 1. Proving a divisibility property by mathematical induction, there is second type of numerical which comes in the university examination and competition also, mathematical induction. Proposition for any integer n greater than equal to 1, that function is 7 की power n minus 2 की power n is divisible by 5. This is our predicate function, that is p of n. For basic step, we substitute that n is equal to 1, that means 7 की power 1 minus 2 की power 1, which is become 7 minus 2, that become 5. 5 is divisible by 5. It means if we take 5 mod 5, that result become 0. Okay. Then inductive step, we assume that for some value of k, this particular function is true, and inductive hypothesis, we must show that it is also true for p k plus 1. So we assume that 7 की power k minus 2 की power k is divisible by 5. So we substitute that, then we assume that 7 की power k minus 2 की power k is equal to 5 dot some value of a belongs to the z, यानी कि some, it means some integer values. Okay, then we need to show that it is also true for p k plus 1. So substitute k plus 1 in place of k, it means 7 की power k plus 1 and 2 की power k plus 1 is divisible by 5. Okay, then 7 की power k plus 1 minus 2 की power k plus 1, we rewrite this equation like this, 7 की power 1 and 7 की power k, after multiplication that becomes 7 की power k plus 1, and similarly 2 की power 1 and 2 की power k, which is equivalent to 2 की power k plus 1. We divide this particular factor because we assume that 7 की power k minus 2 की power k is equal to 5a. So we divide this 7 into two parts, that is 5 dot 7 की power k plus 2 की power 2 dot 7 की power k, which is equivalent to 5 plus 2 become again 7. 7 की power k minus 2 की power k. We take some common part from here. What is common? That is 2. 2 is common, we take 2 is common, then it means 7 की power k minus 2 की power k. Then 5 dot 7 की power k plus 2 dot 7 की power k minus 2 की power k. We assume that it is divisible by 5, so we replace it by 5a. So we replace it by 5a. It becomes 10a. 5 dot 7 की power k plus 10a. ठीक है, we take common, 5 is a common from here, then it means 7 की power k plus 2a. It means dot 5, which is divisible by 5 by definition. So by mathematical induction, we prove that Pn is true for by induction for all value of n which is greater than equal to 1. So take second numerical, that is 8 की power n minus 3 की power n is divisible by 5. So what is basic step? Basic step is put n is equal to 1. If we put n is equal to 1, it means 8 की power 1 minus 3 की power 1, that become 8 minus 3 is equal to 5 is divisible by 5. Okay, then inductive step, we assume that our statement is true for some value of k greater than equal to 1. It means pk is always true, and we have to show that it is also true for k plus 1. So proof continue, that pk, it means 8 की power k minus 3 की power k is divisible by 5. So we replace 8 की power k minus 3k that equal to 5 dot a. ठीक है, from definition that is a belongs to the z. We need to show that 8 की power k plus 1 minus 3 की power k plus 1 is divisible by 5. So we divide that 8 की power k plus 1 into 8 dot 8 की power k. 8 की power k plus 1 into 8 dot 8 की power k, and we divide this 3 की power k plus 1 become 3 dot 3 की power k, and again we divide this 8 dot 8 की power k into 5 dot 8 की power k plus 3 dot 8 की power k. Then it will become, then we substitute value of this from equation, that is 5a, which is become that 5 dot 8 की power k plus 3 dot 5a. What is common from here? Here is 5 is common, then 8 की power k plus 3a, which is divisible by 5 by definition. So by mathematical induction we show that it is true for all value of n greater than equal to 1. So take next example, that is 11 की power n minus 4 की power n is divisible by 7. So what we have to do, we take first basic step, put n is equal to 1 from left hand side and right hand side. What is the value of function? That is 11 की power 1 minus 4 की power 1, that become 11 minus 4, which is equivalent to 7, and 7 mod 7 become 0. It is divisible by 7. So we assume that it is true for any arbitrary value k. ठीक है, then we have to show that it is also true for k plus 1. So we are given that 11 की power k minus 4 की power k is divisible by 7. So we assume that 11 की power k minus 4 की power k, that becomes 7a for some integer value a. We need to show that 11 की power k plus 1 minus 4 की power k plus 1 is divisible by 7. So we expand our 11 की power k plus 1 into 11 dot k 11 की power k minus 4k plus 1, again 4 dot 4 की power k, that become 11 is substitute in divide into two parts, that is 7 plus 4. So it will become 7 dot 11 की power k and 4 dot 11 की power k. What is common here? Here common is 4. Then we take 4 commons and we substitute the value of this from our assumption, that is 7a. So it will become 4 dot 7a. What is common between those two factors? That is 7. So 7 dot 11 की power k plus 4a, which is divisible by 7 by the definition. So this is the mathematical induction for how to solve the divisibility property using mathematical induction. So take one more function, that is n की power 3 minus 4n plus 6 is divisible by 3. So we substitute basic step, that is n is equal to 1. It means 1 की power 3 minus 4 dot 1 plus 6, 1 की power cube, it becomes 1, then 4 dot 1 become 4 plus 6, it will become 3, and 3 is divisible by 3. For inductive step, we assume that our statement is true for some value of k which is greater than equal to 1. Then by inductive hypothesis, we must show that it is true for k plus 1. If it is true for k plus 1, it means it is also true for pk and it is also true for pk plus 1. So we can say that it is true for p1 is true, then p2 is true. If p2 is true, then p3 is true. If p3 is true, then p4 is true. For the inductive hypothesis, we can say that it is true for all value of n. So we assume that k की power 3 minus 4k plus 6 is divisible by 3. So we write this particular function that it becomes 3a, and we need to show that it is also true for k plus 1. So we substitute k plus 1 in place of k, so it becomes k plus 1 का whole cube minus 4k plus 1 plus 6. So we expand the formula of a plus b का whole cube, which is a cube plus b cube plus 3a square b plus 3ab square. Okay, okay. We expand this particular formula, that is k की power 3 plus 3k square plus 3k plus 1, and we multiply 4 into k plus 1, that minus 4k minus 4 then plus 6, okay, which will equivalent to this particular equation. We will get k की power 3 minus 4k plus 6. We take three terms which is, we assume that it is true, k की power 3, so we take k की power 3 and minus 4k and plus 6. One side we take k की power 3 minus 4k plus 6, and remaining other factors are written here, that is 3k square plus 3k minus 3. We assume that this particular function is true, so we substitute here 3a, and what about the remaining? Remaining 3 is common, so 3 dot k square plus k minus 1. So we take 3 common from these two, then what will we get? We get a plus k square plus k minus 1, which is divisible by 3 because 3 is in the multiplication of some integer value, because of a is an integer, k is an integer, and integer plus integer result is always integer. So it is true for all value of n which is greater than equal to 1. So we take third type of numerical, which is inequality numerical, so that n factorial is greater than 3 की power n for n greater than equal to 7. So what is the basic condition is? Basic condition is n must be greater than equal to 7. If this is the initial value of n, it means p of a. What is the value of initial value of a? A is 7. So for base case we can compute that P7, not P1 here, okay? We use P7 because the initial value of n for this particular formula is true for basic condition initial value, that is the that is the n equal to 7. So what is the value of 7 factorial from left hand side? That is 7 factorial 7.6.5.4.3.2.1, which is equivalent to 5040, and which is greater than 3 की power 7. 3 की power 7 become to 187, which is true. So for inductive step, we assume that pk holds, this particular function is true for any value k. K is always greater than 7. For k greater than 7. For k greater than 7 and equal to. So we take pk plus 1, that becomes, we must show that k plus 1 factorial is always greater than 3 की power k plus 1 is always true. For this we take, this is our assumption, this is particular equation is true, so we multiply 3 in both side, so it will become 3 dot k factorial greater than 3 dot 3 की power k. We can say that it is 3 power 1 and it is 3 की power k, so it will become 3 की power k plus 1, okay. Then we replace this particular 3 with k plus 1, because of k plus 1 is always higher than 3, so we replace 3 by k plus 1, so it is always greater than previous value, that is 3 dot 3 की power k. So it will become, what is the formula of k plus 1 factorial? That is k plus 1 dot k factorial. It means 3 factorial is always equal to 3 dot 2 factorial. N factorial is always equal to n dot n minus 1 factorial. This is formula we have studied in mathematics. Then it is true for, thus Pn is true for by induction. So then next question, that is show that n is less than 2 की power n for n greater than equal to 1. So base case, so we put initial value, that is P1, then 1 is less than 2 की power 1, which is true. and we, for inductive step, we assume that it is true for pk, that is, it means k less than, so we assume that it is also true for pk plus 1. So pk, we have to show that k plus 1 is less than 2 to the power k plus 1 is true. Adding 1 both side in which we have assumed that this is particular true, k less than 2 to the power k. If we add 1 both side, it means k plus 1 is less than 1 plus 2 to the power k. We replace this 1 by 2 to the power k because it is true for all value k greater than 1. So the value of from the right hand side is always greater than from left hand side. So we replace by 2 to the power k. So what will it become? 2 to the power k plus 2 to the power k become 2 dot 2 to the power k. 2 dot 2 to the power k. It become 2 dot 2 to the power k. So we can write that 2 to the power 1 and 2 to the power k, which is k plus 1. So it is true. Thank you.